Hello classmates, we are Fantastic Four.
Before we start, I'd like to introduce our group members. First, SYAHIRAH. Second, AINUN AQILAH. Third, INTAN NURSYAHIRA. And last but not least, AIDA SYAZANA.
Let me introduce to you what is Newton's second law. Newton's second law is when a force acts on a body, acceleration is produced which is proportional to the force. The greater the mass of the object being accelerated, the more force is required to accelerate the object. Therefore, heavier objects require more force to move the same distance as lighter objects. Newton's second law said that the net force on a body is equal to the product of the body mass and its acceleration, where F equal to m times A, where F is the net force, m is the body mass, A is the acceleration.
For the discussion, a skydiver of mass 70 kg has jumped out of a plane 2 miles above the surface of the Earth. After 20 seconds, he has reached terminal velocity, meaning he is no longer accelerating. What is the force of the air on the skydiver's body?
In this video, it shows the illustration example for our discussion.
Daddy Pig! Wait for me, Daddy Pig! Whee! Mummy Pig has jumped! She is going to rescue Daddy Pig! Got you! Oh, she's got him! Hooray!
As for calculation, the weight of a skydiver is the gravitational force exerted on it by the Earth. By using W is equal to mg, that is always pointing downward, the weight of the skydiver is 686.7 Newton, which is the multiplication of 70 kg by 9.81. Thus, to find the force of the air, the vertical motion is considered F equal to ma, which results a resistance of 686.7 Newton.
The question contains terminal velocity and Newton's second law. Since the skydiver is at terminal velocity, the force of the air is equal to the force of gravity, resulting in zero net force and thus no acceleration. We just need to calculate the force of gravity on the skydiver to find the force of the air.
For more explanation, as soon as a skydiver jumps about 2 miles up in the air, it will falling really fast, and in fact at a speed about 100 miles per hour. We could say that a person was plummeting. The reason why a skydiver falling so fast is the Earth's gravity has a hold on them and it's pulling them down. The best way to counteract the effect of gravity is to pull the rig cord on the parachute. As the parachute above us expands, it will catch air, and the force of that air pushing against the parachute creates a lot of air resistance. As you can feel, the air resistance is very strong, so much so it is equals to the pull of the gravity. And the two of them will cancel each other out. We're still heading to the Earth, but instead of plunging downward at 100 miles per hour, a skydiver will softly floating through the sky at a speed of around 10 miles per hour. So even though if we jump at 10,000 feet thanks to the air resistance, the landing feels more like jump off a 4-foot wall.
That brings us to the end of the video. I'd like to summarize by saying Newton's second law give an explanation for how objects whose forces are out of balance react. According to the law, when there are imbalanced forces acting on an item, the object will accelerate with accelerations that is inversely proportional to the mass and directly proportional to the net force. Thank you so much for your interest and attention. Bye bye.